Hi, today we'll be solving exam questions on AQA A-Level Physics, and it'll be a small short video today, and we'll be just solving A-Level Physics AQA questions on straight line one dimension motion. Let's start. Question number 1. An object is released and falls from rest. Okay, as I've always been telling you, always draw the diagram. Even if it is a one marker, there's no harm in making a simple line diagram, especially when we are learning. An object is released from rest. Released from rest, that means its starting velocity is 0. Falls from rest, okay, and obviously because it's falling, the acceleration will be acceleration due to gravity. Air resistance is negligible. After falling for time t, what is the momentum of the object? Now, if it has fallen for time t, let's say after falling for time t, it has reached somewhere here, what will be its velocity? Its velocity will be u plus at. So v is equals to 0 plus gt. So velocity is proportional to t. And because momentum is denoted by p, so is mv. Momentum is proportional to v, v is proportional to t, so momentum is directly proportional to t. That's it. Okay, so the answer would be C. A ball is dropped from a height h. The ball hits the ground with velocity v, so it's dropped from a height h. U is 0. And when it hits the ground, so this is h, it hits the ground with a velocity v. Okay, so we're just going to write down this equation of motion. So u squared plus 2as, because initial velocity is 0, we'll write 2gh, acceleration will be g. So my v square is 2gh. Case 2, where it is dropped from a height 2h. Okay, see, still the u is 0, but the height is now 2h. So with what velocity would it hit the ground? So again, I'm going to use the same equation. Okay, I'm going to just move it this side. Okay, so v square equals to u squared plus 2as. This is 0. A is g. This is 2h. So now, as you can see, I'm getting the velocity as 4gh. So how many times is the initial one? So what is the relationship between so I'm just taking this as v1 and v2. So just dividing, I'm getting, so if you divide these two, you'll get 2. So v2 is root 2 times v1. So that is C. Or if you are good at the rearranging or proportionality questions, you can just do from here. C. What is the relationship between, I'm just going to do this. If you want to see what I've done, see, I don't know what's the word, but if you want to just see what I've done, you just pause the video, rewind and go back. I'm just doing by another method. I know this is my equation. So my velocity squared is proportional to height, because rest everything is constant. This is 0, a is constant g. So my v square is proportional to height. So when height doubles, for this to satisfy, this should become root 2 times. It's the square root of double. So because this is square, so okay, let's say another example. Let's say if your height triples, some other question. If the height triples, what do you think the velocity would be? Right, take a guess. Yes, it would be root 3 times. Okay, so in this case, it will be root 2. Either this method or this method. Initially, you would be using these methods. Once you get comfortable with the equations, you will end up solving these kinds of method also. All right, let's see the next one. In 2021, the world land speed record was this much. Okay, This was the average speed achieved by a jet power car in 2 runs. Each run was measured over a distance of 1.61 kilometers. The average speed for one of these runs was 343 meters per second. Calculate in S the time taken, calculate in seconds, the time taken for the car to complete the other run. Alright, so the two, I'm just doing the straight line. So 2 runs, okay. Each run was 1.61 kilometers, so I'm just converting it into meters. So 1610 meters. So each one is 1610 meters, okay. The average speed for one of these runs was 343 meters per second. So for this one, let's say the average speed is 343. So how much time it would take for the first one, and then what it has done is it has given you the average speed for the entire journey. So for the first journey, A to B, we have speed as 343, we have distance 1610, so we can calculate the time is 1610 divided by 343. And then for the same, then B to C, the distance is 1610, we don't know the time, and we also don't know the speed. Okay, so if we can calculate what is the, for the total entire two A to B, B to C, what is the average speed? It's 1230 kilometers per hour. So for the first A to B, let's calculate the time. So the time would be, if you divide 1610 by 343, let me just use my calculator. So this is giving me around 4.69. So this time is 4.69 seconds. And then can I calculate the total time of the journey? Total time of the journey would be, the total distance traveled is 1610 plus, we need to convert 1230 kilometers per hour into meters per second. So to convert that, I'm just multiplying it by 1000 to convert it into meters, and then divide by 3600 to convert it into seconds, which gives me around 341.7 meters per second. So if I plug it here, I will get the total time of the journey. So the total time of the journey is coming around 9.42 seconds. Okay, so we got the total time of the journey, we got the time for the first run as 4.69 seconds, and now can we calculate this time? So this time would be then 9.42 minus 4.69, we get this time, and then we calculate the average speed for the next journey, which is divided by 9.42 minus 4.69, which will give me the average speed as around 340.3. Okay, we don't need the average speed, we need the time. All right, so what we need to understand here is that we need to have our significant figures as 3 in the final answer. If you have less than 3 significant figures in your final answer, we are not getting the full marks then. Okay, engineers are designing a new jet powered car to break this record. All right, so they want to break this record. She shows a variation of a speed with distance of the car. So this is speed and distance. The car reaches the maximum acceleration when it is at 5600 meters from the start. So at 5600 meters, I'm just going to zoom it further to be able to see 5600 meters. So this is 4000, this is 5000, and each line is how much? So 5 lines are for 1200, 52, 54, 56. So this is 56. Yeah, that's right. Yeah, so that's 56. So 450 meters per second. Okay. Now, what is it asking? Determine the kinetic energy of the car at this maximum acceleration. So kinetic energy is half mv squared. Mass is 6.50 10 to the power 3 times, how much we were getting? 450. And then we square it. So we get the answer as, final answer as 6.6 10 to the power 8 joules. The percentage of input power. So what's the percentage of the input power? Well, why are we getting that percentage? Okay. No, I think this has come from somewhere else. Or we can just, yeah, I think this does not belong here. This does not belong here. So we got the kinetic energy as this many joules. Right, let's see the next one. Which combination of an object's speed and journey time gives a distance traveled of 1 mm? Okay, so the distance is just speed times time. Micro is 10 to the power minus 6. Okay, so we're going to just convert 10 to the power minus 10 into 10 to the power minus 6 times 100, which is 10 to the power minus 3, which is 1 mm. Oh, we got the first one as our answer. So first is the answer. Okay. Or you can just, kilo is, you convert it by times in by 1000. Micro is 0.01 times 10 to the power minus 6. You times them. Nano is 10 to the power minus 9. Giga is 10 to the power 12 times. Million is 0.1 times 10 to the power 6. And nano is 100 times 10 to the power minus 9. Yeah, giga is 9, 10 to the power 9. Okay. Question number 5. A ball is thrown vertically upwards. So we're throwing the ball vertically upwards. Say, this is not a straight set. If I throw this ball vertically upwards and it returns to its original position. Why I'm making wrong diagrams? Okay, let's just try. Wait, I think my laptop is not perfectly straight. That's why my figures are not coming perfectly straight. Okay, so my ball is going vertically upwards and, oh, that's perfect. So this is 2.4 seconds later. The effect of air resistance is negligible. What's the total distance traveled by that ball? Okay, so what you can do is, to calculate the total distance traveled by the ball, we can use, okay, I am going to use this. If I use S equals to ut plus half AD square, this equation will give me displacement. And the displacement of this is 0 because it is coming back to the original position. So this is of no use. What I have to do here is, I have to break this journey into two parts, calculate to what height it is reaching, and then times it by 2 to calculate the total distance traveled. Okay, now at the maximum height, the velocity will be 0. That's why it is at maximum height. It's not going any further. That means at maximum height, its velocity is 0. Now, if it is taking 2.4 seconds to come back, it must be taking 1.2 seconds to reach the maximum height, because no energy losses are happening. So I'm going to use v squared. No, I can't use that. I am going to use, let's see. So I have v equals u plus at. Final velocity is 0. Use the velocity, it was thrown upwards at, so it was thrown upwards at u speed. Gravity is minus. Now, why is gravity minus? Now, that's one question. The gravity is negative because it is going in upward direction and the gravity is in downward direction. Whenever the velocity and acceleration are opposite to each other, you take acceleration as negative. Okay, so the acceleration, the value of the acceleration is 9.81. So we're just going to plug in. The value is 9.81 and the time it has taken is 1.2. So my u is 9.81 times 2, which is 19.62 meters per second. So this is the initial velocity with which it was thrown upwards. And then what we can do is we can calculate the maximum height using this equation. Yes, final velocity is 0. Initial speed is 19.62 squared minus 2 times 9.81 times the height, and then 2 times 9.81 times height is equals to 19.62 squared. So my height is 19.62 meters. So if my height, the maximum height it is rising and it's 19.62 meters. So the total distance traveled would be going up and coming down. So what we just do is we have calculated the total height. It goes up 19.62, some comes out, so we're not getting the answer. Oh my god, we did a mistake here. It's 9.81 times 1.2, not times 2. Oh, the calculation errors. This is horrible. Okay, so method is still the same. We're going to just redo it. Just use your calculator till I'm erasing. So my u here is 9.81 times 1.2.